In today's video, we will start with the question 11. So in the question 11, 230 men took part in a physical fitness test and were required to do pull-ups. The number of pull-ups done by the men is shown in the frequency table below. So now here we have the data regarding the pull-ups in the physical fitness test done by 230 men. Now this data divided into class intervals. That means we have a grouped data. And there are corresponding frequencies and correspond to each class interval. So the first class interval is 0 to 6, second class interval is 6 to 8, third class interval is 8 to 10, and so on. Also, these class intervals show us the number of men that falls under the corresponding class interval. So that means 69 men do pull-ups ranging from 0 to 6. 63 men do pull-ups ranging from 6 to 8, and so on. Frequency is the rate at which something occurs. So now we will try to add all the frequencies. So 69 plus 63 plus 28 plus 24 plus 19 plus 14 and plus 13 gives us the total frequency of 230. Now this is a frequency distribution among various class intervals of the number of pull-ups. Frequency distribution can easily be converted into a cumulative frequency distribution. In cumulative frequency distribution, we have to add the frequency at every single stage. So now, before calculating the cumulative frequency, we will see why it is called more than type cumulative frequency, since there we have x greater than equals to 0, x greater than equals to 6, so it means this is a more than type cumulative frequency distribution. So we are going to take lower limits we are going to say something more than 0, something more than 6, something more than 8, something more than 10, something more than 12, something more than 16, and something more than 20. So in more than type, we have to remember that we will work with only lower limits. So when we are going to calculate the cumulative frequency of everything more than 0, it means the frequency from 0 to 25. So every frequency will fall under this class interval. So we know that the total frequency is 230. So the first entry of the cumulative frequency table is 230. Cumulative frequency of everything more than 6 will be 63 plus 28 plus 24 plus 19 plus 14 plus 13, because obviously these frequencies fall under the class interval more than 6, and we will exclude 69 because it is lesser than 6. So in other words, we will do 230 minus 69 gives us the cumulative frequency of 161. For more than Similarly, for more than 8, we will calculate cumulative frequencies from 8 to 25. That is 28 plus 24 plus 19 plus 14 plus 13. And we will exclude 69 and 63. 69 was already excluded, so we will do 161 minus 63, and it will give us the cumulative frequency of 98. For the next class interval, more than 10, we will calculate cumulative frequencies from 10 to 25, in other words, 24 plus 19 plus 14 plus 13. And we will exclude 69 and 63 and 28. Since 69 and 63 already excluded, so 98 minus 28 gives us the cumulative frequency of 70. For the fifth class interval, more than 12, we will calculate cumulative frequencies from 12 to 25, and in other words, 19 plus 14 plus 13. We will exclude 69, 63, 28, and 24. So 70 minus 24 will give us the cumulative frequency of 46. For more than 16, we will calculate cumulative frequencies from 16 to 25, in other words 14 plus 13, and we will exclude 69, 63, 28, 24, 19. So 46 minus 14 will give us the cumulative frequency of 27. Now for the last class interval, more than 20, we will calculate cumulative frequencies from 20 to 25, in other words 13, and we will exclude 69, 63, 28, 24, 19, and so 27 minus 14 will gives us the cumulative frequency of 13. In modern type, the first cumulative frequency value is equal to the total frequency. So here we can see that the first cumulative frequency value is equals to the total number of frequencies. So hence this is a completed more than type cumulative frequency table. Now in the part 2, explain why it is not possible to state the number of men who did more than 8 pull-ups. The cumulative frequency table is based on more than or equal to frequency. Since it is not possible to find out the number of men, who did exactly 8 pull-ups. And it is not possible to find out the number of men who did more than 8 pull-ups. Now the part 3, the men have to do at least 12 pull-ups to achieve the gold award, 8 to 11 pull-ups to achieve the silver award, and 6 to 7 pull-ups to achieve the bronze award. Using the table in the part 1, find the number of men who achieved the in the part A gold award. So we have to find out the number of men who achieved the gold award. So for the gold award, men have to do at least 12 pull-ups. So we have to search the value for at least 12 pull-ups, and the corresponding frequency for the number of pull-ups at least 12 is equals to 46. So the number of men who achieved the gold award is equals to 46 according to the table. Now for part 3b, we have to find out the number of men who achieved the silver award. So we have to find out the number of men who achieved the silver award. So for the silver award, the men have to do 8 to 11 pull-ups. So for 8 pull-ups, we have the frequency 98, and for the since there is no information regarding 11, so we will see the value for the 12 pull-ups, and this value is 46. So we will take away 46 from 98 and we will get 52. So the number of men who achieved the silver award is equals to 52. For part 3c, we have to find out the number of men who achieved the bronze award. So in the question, to achieve the bronze award, men have to do 6 to 7 pull-ups. So we will see the information regarding 6 to 7 pull-ups in the counter frequency table. So here we have for 6 number of pull-ups, the frequency is 161, and for since there is no information about regarding 7 pull-ups, so we will see the number of 8 pull-ups. So the frequency for the number of 8 pull-ups is 98. So We will subtract 98 from 161 and it will give us 63. So the number of men who achieved the bronze award is equals to 63. Now the part 4. If a man is chosen at random from the 230 men, find the relative frequency that he has achieved the gold award. So here to find out the relative frequency, we have the formula number of occurrences divided by total number of trials. So here the number of occurrences in our case is the number of men who achieved the gold award, and since we have find out the number of men who achieved the gold award in the part 3a, and that was 46 divided by total number of trials. In our case, the total number of trials is the total number of men, and that is 230. Can simplify it further with the help of table 2. So we have 2 2s are 4 and 2 3s are 6, and here we have 2 1s are 2 and 2 1s are 2 and 2 5s are 10. Further simplification gives us 23 5s are 115, so it will be equals to 1 over 5. So the relative frequency that he has achieved the gold award is equals to 1 over 5. In the question 12, the table below shows the average monthly water consumption of 50 households. In the part 1, construct a frequency table for the given data. So first we have to identify the class intervals from the given cumulative frequency table. So the class interval are, since this is a more than or equal to type cumulative frequency, so the class intervals will be look like 0 less than equals to x less than 3, 3 less than equals to x less than 10, 10 less than equals to x less than 15, 15 less than equals to x less than 20, 20 less than equals to x less than 25, 25 less than equals to x less than 31, 31 less than equals to x less than 35, and 35 less than equals to x less than 40. Now to find the frequency of the class interval 0 to 3, subtract the cumulative frequency of the next class interval 3 to 10 from the cumulative frequency of the current class interval 0 to 3. So 50 minus 47 will give us the frequency of 3. To find the frequency of the class interval 3 to 10, subtract the cumulative frequency of the next class interval 10 to 15 from the cumulative frequency of the current class interval 3 to 10. So 47 minus 40 will give the frequency of 7. To find the frequency of the class interval 10 to 15, subtract the cumulative frequency of the next class interval 15 to 20 from the cumulative frequency of the current class interval 10 to 15. So 40 minus 25 will give us the frequency of 15. To find the frequency of the class interval 15 to 20, subtract the cumulative frequency of the next class interval 20 to 25 from the cumulative frequency of the current class interval 15 to 20. So 25 minus 12 is equals to 13. Similarly, to find out the frequency for the class interval 20 to 25, subtract the cumulative frequency of the next class interval 25 to 30 from the cumulative frequency of the current class interval 20 to 25. So 12 minus 6 will gives us the frequency of 6. To find the frequency for the class interval 25 to 31, from the subtract the cumulative frequency of the next class interval 31 to 35 from the cumulative frequency of the current class interval 25 to 31. So 6 minus 3 is equals to 3. To find the frequency for the class interval 31 to 35, subtract the cumulative frequency of the next class interval 35 to 40 from the cumulative frequency of the current class interval 31 to 35. So 3 minus 1 is equals to 2. Now for the last class interval 35 to 40, the frequency will be equals to 1. Since we are dealing with the group data and the class widths are unequal, so we need to find the frequency density, and we use it to draw the histogram also. So here we will find out the class width. We can find out class width by subtracting the lower limit from the upper limit of the class interval. So 3 minus 0 is 3, 10 minus 3 is 7, 15 minus 10 is 5, 20 minus 15 is 5, 25 minus 20 is 5, 31 minus 25 is 6, 35 31 minus 31 is 4, and 40 minus 35 is 5. Now we will find out the frequency density. We can find out frequency density by dividing the frequency with the class width. So 3 divided by 3 is equals to 1. 7 divided by 7 is equals to 1. 15 divided by 5 is equals to 3. 13 divided by 5 is equals to 2.6. 6 divided by 5 is equals to 1.2. 3 divided by 6 is equals to 0.5. 2.4, 2 divided by 4 is equals to 0.5. And 1 divided by 5 is equals to 0.2. So this column shows the corresponding frequency densities. The part 2, on a sheet of graph paper, draw a histogram to represent the frequency distribution. So to plot the histogram, we will plot the frequency density of each class interval as a bar on a graph, where the x-axis represents the class interval and y-axis represents the density frequency, with the height of each bar corresponding to the frequency density of its respective class interval. So here we will draw a y-axis. So here we will draw y-axis, and here we will draw x-axis. So along x-axis we will take average monthly water consumption, in x meter cubes, and along y-axis we will take frequency density. So we'll start with the scaling points 0, 1, 2, and 3. Along x-axis we have 3, 10, 15, 20, 25, 31, 35, and 40. So for the class interval 0 to 3, we will draw a bar of the height 1. Now for the class interval 3 to 10, we will draw a bar of the height 1 again. Now for the class interval 10 to 15, we will draw a bar of the height 3. Now for the class interval 15 to 20, we will draw a bar of the height 2.6. So here we have 2, 2.2, 2.3, 2.4, and 2.6. Here we have 2.6. Now for the class interval 20 to 25, we will draw a bar of the height 1.2. So here we have 1.2 somewhere here. Now for the class interval 25 to 31, we will draw a a bar of the height 0.5. Similarly for the class interval 31 to 35, we will draw a bar of the height 0.5 again. Now for the class interval 35 to 40, we will draw a bar of the height 0.2. So this is the histogram to represent the frequency distribution. 3. Now in the part 3, if a household is selected at random from the 50 household, what is the most likely interval of average monthly water consumption of the household? So we have to find out the class interval that shows the most likely of average monthly water consumption of the household. So the interval having the highest frequency is 15 and the class interval is 10 to 15. So the required class interval is 10 less than equals to x less than to 15, having the frequency 15. So the average monthly water consumption of household most likely to be occur will be at least 10 millimeter squares, 10 millimeter cube, but less than 15 millimeter cube. Now, if two households are selected at random from the 50 households, found the relative frequency that the average monthly water consumption of households will be at least 20 meter cube, but less than 35 meter cube. So, at least 20 meter cube. So here we have to first we have to find out the number of households whose average monthly water consumption will be at least 20 meter cube, but less than 35 meter cubes. So here we will add up the frequencies of the three class intervals. The first is 20 to 25 having the frequency 6, 25 to 31 having the frequency of 3, and 31 to 35 having the frequency 2. So 6 plus 3 plus 2 is equals to 11. And now to find out the relative frequency. Now to find out the relative frequency, we will use the formula equals to number of occurrences divided by total number of trials. So here the number of occurrences corresponds to the number of households whose average monthly water consumption will be at least 20 meter cube but less than 35 meter cube, and that is 11, divided by total number of households, and that is 50, multiply by, since we have to find out two household at random, so since we have already selected one house already, so the total number of houses left is equals to 49, and since we have already selected one household having the average monthly water consumption will be at least 20 meter cube but less than 35 meter cube, so the number of households left is 10. Now after simplification with the table of 5, here we have 5 2s are 10 and 5 10s are 50. Further simplification gives us 2 1s are 2 and 2 5s are 10. So here we have 11 divided by 5 multiplied by 49 will gives us 245. So the relative frequency that the average monthly water consumption of the households will be at least 20 meter cube but less than 35 meter cube is equals to 11 over 245.